Right, now accelerations, we start off with the definitions, is defined as the rates of change of velocity. Now, so what we know here is that when we see the word rates of change, essentially it means how fast one entity changes with respect to time. Alright, so in this case we'll say that how fast velocity changes with respect to time, and that will give you the acceleration. Now we know that velocity is a vector. So in this case, if velocity is a vector, so is acceleration. Okay, so take note of this. Now, this is the equations, which is a very important equations for you to learn to calculate accelerations. A equals to v minus u over t. A stands for the acceleration. SI unit for acceleration, you need to know here, meter per second square. V is this final velocity symbol. U is the initial velocity, which is all in meter per second. T is the time that the object takes to change its velocity from u to v, and the SI unit for time is in seconds. So how do we apply this formula? Let's take a look at example 1. I have a car starting from rest. It is accelerated uniformly to 48 meters per second in a time of 10 seconds. Calculate the accelerations of the car. Right, so we're going to write down all the information given. You have the initial velocity, u, 0 meter per second. Final velocity, v, 48 meter per second. Time taken, 10 seconds. Substituting in the values, you get the accelerations as 4.8 meter per second square. Now, very importantly, I want you to take note that this formula can only be used if the acceleration is uniform. So if the acceleration is not uniform, we are not supposed to use this formula. Okay? Now, of course, when the object changes its velocity to go faster and faster, we say that the object is accelerating. Now, on the other hand, if the object is slowing down, in this case, we will actually call it as deceleration. So in this case, we can say that the object is experiencing or undergoing deceleration or retardation, or we also can call it negative accelerations. All three are equivalent terms. Alright, you have this example 2. A train slows down from 60 meters per second to rest, time of 1 minute. What is the retardations of the train? So we look at the solution. All the information is given. Substituting into the formula, you end up with minus 1 meter per second square. So accelerations is negative 1 meter per second square. Now retardation is understood to be negative acceleration. So when we present the answer, we don't need to put in a negative sign. So which means that essentially it's just 1 meter per second square to refer to retardation. So acceleration is said to be uniform if it remains constant over a period of time. So let's take a look at this example 3. I have a velocity of a car increases from rest to 9 meters per second in first 3 seconds, and then from 9 to 27 in the next 6 seconds. So is the accelerations of the car uniform? So if you're going to calculate all the accelerations during the next within the 2 intervals of time, you'll realize that the acceleration is the same value. Right? So if we can achieve the same value for both time frame, we can conclude that the accelerations of the car is uniform. Right, we're going to look at speed-time graph. The speed-time graph has got very close relationship with its accelerations of the object. Essentially, this is a very important fundamental concept. The gradient of a speed-time graph gives the accelerations of the object. Okay, the gradient of a speed-time graph gives the accelerations of the object. Take a look at some of the common speed-time graph we have. First one and the second, the gradient is 0. So gradient 0, what does it mean? Is that there is no accelerations. So 0 gradient equivalent to 0 accelerations. This is regardless of whether the object is at rest or is already in motion. Okay, as long as 0 gradient, 0 acceleration. Okay, take a look at 3 and 4. So you look at this. This is a positive gradient. Okay, and this is a negative gradient. So when we have a positive gradient, it means constant acceleration. If we have a negative gradient, it means constant deceleration. Now, of course, the gradient value has to be constant also, so that's why we can say it's a constant acceleration for this and constant deceleration for this line. Okay, take a look at this. Now, here you have the gradient which is getting less and less steep. So initially it's very steep. Now towards the later part, you see that the gradient gets more and more gentle. Now how do you know the gradient gets more and more gentle? You can essentially just draw a tangent at this point as well as a tangent at this point. You'll notice that the tangent here, the gradient is less than the gradient of the tangent here. Okay, so in this case, we have what we call a decreasing acceleration. Essentially, it means the velocity is still increasing, but towards the end is increasing at a decreasing rate. Take a look at this graph. You look carefully at the gradient at the beginning and towards the end. Initially, the gradient is gentle. Towards the end, the gradient actually gets more and more steep. So in this case, we can say that the object is experiencing increasing acceleration, right? Increasing acceleration. Alright, and then we have this too. Essentially, it means that this part, initially the deceleration is very fast. Towards the end, the gradient gets more and more gentle. So, it's a decreasing deceleration. So, the speed slows down very fast at the beginning, but towards the end, the speed slowing down process gets slower. Alright, so similarly for this, the initial stage, the speed is decreasing at a slow rate. Towards the end, you look at the gradient gets more and more steep. Essentially, it means that the deceleration rates gets faster. So the gradient here represents a faster deceleration as compared to the beginning. So this is the end of the video lecture on acceleration. Thank you for your attention.